Hi, and welcome to 2.3 of College Algebra's trig section, solving right triangles. So, big thing with solving a right triangle is you are finding all of the missing sides and angles. Typically means you have to know at least three pieces to find the other three pieces, because triangles have six components, three angles and three sides. So, on this first one, also we're going to recognize that we put C as the right angle. That's so we can put little c, because big letters and little letters are always opposite each other of matching pieces, where our littles are our side lengths and our capitals are our angles. The reason we put little c right there is because we're used to the Pythagorean theorem that has c squared by itself, because you always isolate the hypotenuse. So in order to solve a right triangle, you need to know at least three pieces. So over here, we know that little c is 12, we know that big A is 40, and we know that big C is 9. Now, knowing this, again, means we need to find the three missing pieces. Well, which three pieces do we not know? We don't know little a, we don't know little b, and we don't know big B. So those are the three pieces we are going to solve for. So we should always start on the information we know. I know big A is 40 degrees. So if I draw theta from that perspective, I can label my side lengths. So 12 would be my hypotenuse. A is going to be my opposite. And little b is going to be my adjacent. So if I'm looking on for A, I need to use my hypotenuse. I'm trying to find my opposite, so I want to use the trig ratio that uses opposite and hypotenuse. So that would be, of course, if we're using SOHCAHTOA, I'm going to use sine that uses opposite and hypotenuse. So sine of A, which is 40 degrees, equals opposite A over hypotenuse 12. Now it's just a matter of getting A by itself, so I can multiply both sides by 12. So we get A equals 12 sine of 40. And I can type this in my calculator as long as my calculator is in degree mode. So degree mode up there. Remember, I can always change it by going to mode down to degree and entering a degree. So 12 sine 40, we get 7.7. Okay, little b. Now, because I technically know side A and side C, I could Pythagorean theorem here. However, I like to use the information I started with, because if I messed up on here, I want to avoid potentially causing another mistake. So now I'm going to use hypotenuse still and my adjacent. So which trig ratio uses adjacent and hypotenuse? That would be cosine. So we get cosine of 40 equals adjacent little b over hypotenuse 12. So I can multiply both sides by 12. So we get little b equals 12 cosine of 40, which again we can type directly into our calculator. So we get little b is about 9.2. Okay. And then big B, we have to recognize that three angles of a triangle always add up to 180. And because I know A is 40 and C is 90, I can solve for B that way and find that B has to be 50 degrees. Now, the nice thing about triangles is their sides and angles are proportional. What I mean by that is, what's the biggest side of a triangle? It's the hypotenuse that is opposite the right angle. So sides opposite a bigger angle are always bigger sides. So in this case, A is 40 degrees and B is 50 degrees. B is bigger, which means side B has to be bigger, in which case we got 9.2 versus 7.7. So this holds as well. Nice little double check there. Okay, well, what if I knew two sides? Well, now what three pieces am I missing? I'm missing a third side and I'm missing both angles. So I would just pick one of my angles. It doesn't matter which. For the sake of argument, I'm going to pick angle A and put my theta there. From the perspective of theta, 3.41 is my adjacent, 2.73 is my opposite, and C is my hypotenuse. So I need to find little c, big A, and big B. And again, nice thing is, functionally, these just turn into three separate problems. So for example, I can solve for little c because I have two other sides. I can use the Pythagorean theorem. So a squared plus b squared equals c squared. So therefore, c equals the square root of a squared plus b squared. I'm sorry, that would be b technically, because little a would be 2.73. So we get c is about 4.37. Okay. Now to find A, I identified 2.73 as my opposite, 3.41 as my adjacent. So I could do tangent of A equals opposite 2.73 over my adjacent 3.41. So then A equals tangent to the -1 of that. So we get 38.7 degrees. And then B, I could say that all triangles add up to 180, or you could also do tangent as well. It's just that the opposite and adjacents flip. So now you have 3.41 over 2.73. So 51.3. Okay. One thing that might come up that we didn't really discuss here is, let's say I have a triangle such that it's 34 and we have 17 and x. Well, x is my adjacent and 17 is my opposite. So I would do tangent of 34 equals opposite over my adjacent. You always, always, always multiply by the denominator. So I get x tangent 34 equals 17. And then I would divide, in this case, by tangent of 34. So in my calculator, I would type 17 divided by tangent of 34. So be careful with that. Okay. Next one. We're given a circle here, and we're given these 18. These 18 are both the radius. Okay. But the nice thing is, okay. And then we have a line that is perpendicular to the circle. It'd be called tangent to the circle, funnily enough. So solve for x. Well, from the perspective of this 35, this 18 is my opposite, and this entire side length is my hypotenuse. So what trig ratio uses opposite and hypotenuse? That would be sine. So we can write sine of 35 equals opposite over hypotenuse, hypotenuse being the entire side length. This chunk is x, this chunk is 18. So that would be x plus 18. So again, we always multiply by the denominator. So I'm going to multiply by x plus 18. So we get sine of 35 times the quantity x plus 18 equals 18. And here, I want to get x by itself. So I'm actually going to divide by sine of 35, just like we've done on this example right here. And then one more thing I can do to get x by itself is subtract this 18. So x equals 18 over sine 35 minus 18, which I can type all of that into my calculator. So x would be about 13.4. Thank you for listening, and I hope you have a great day.